Welcome guys. In this lesson we are going to focus on two questions from additional mathematics paper 1 for the 2023 for the internal. So we are starting from question 6. We are told to prove the identity 2 over cos raised to the power 4 minus sine raised to the power 4 plus 1 is equal to sec squared. So to prove simply means we want to verify, we want to show that the left side is equal to the right side. Now, what I prefer to do is you work the side where you have cos and sine. So we are going to focus on the left side, so say left hand side. So I'm going to write the original expression 2 divided by cos raised to the power 4 minus sine raised to the power 4 plus a 1. Now for you to understand what I'm going to do here, let me say if we have x raised to the power 2 in brackets raised to the power 2, this can be simplified as, according to the laws of indices, we can multiply the exponents, giving us x raised to the power 4. So if I have this, I can reverse back to this. So that's a concept that we are going to use here. So let's do that. So instead of writing cos raised to the power 4, I'm going to write cos raised to the power 2, then enclosing brackets, squared, sine raised to the power 2, enclosing brackets, squared, plus a 1. Now at this point, we can factorize this side. Now we can use the difference of two squares, where if you have a squared minus b squared is equal to open brackets, you need to have two pairs of brackets. You put a. One must have a plus, minus, b. So that's what we are going to do the other stage. Right, so I'm going to open two pairs of brackets plus this one here. So cos squared minus sine squared. Here we are going to have cos squared plus sine squared. Now upon reaching here, we are going to now bring in the concept of Pythagorean identities, where we are told cos squared plus sine squared. So this is one of the identities that you need to know, must equal to 1. So where there is this part here, we are going to substitute with 1. Right, so we proceed from here. Now, from the same identity, we can make sine the substitute formula so that we get rid of the sine from the denominator part. So I'm going to shift cos to the right side, giving me sine squared is equal to 1 minus cos squared. So at this point, this is what I'm going to substitute where there is sine. So say cos squared minus 1 minus cos squared, then we have plus 1. Now I'm going to distribute the negative. So negative times 1 is negative 1. Negative times negative will give us positive cos squared plus 1. We can now collect the like terms. So the like terms will be cos squared plus another cos squared minus 1 plus 1. So we can cancel this. So cos squared plus cos squared will give us 2 cos squared. So if I cancel this, then I'm going to have 1 over cos squared. So according to the identity, 1 over cos squared is same as the sec squared, so hence shown. Right, we move on to question 7a. The term independent of x in the expression of, we have k over x squared plus xc enclosed in brackets multiply, raised to the power 9 is 61,236, where k is a constant. Find the value of k. So for a question like this one, we are going to now bring in the formula. So say we'll say n combine r multiply by a raised to the power n minus r, then times b raised to the power r. Now from the expression that we have, n is equal to the power. So in our case, n is equal to 9. R, we don't have the r. So what else do we have? A is this term, the first one from this expression. So this is our A. Then this will be our B. Let's now do substitution. So I'm going to say n is equal to 9. R, we don't have. A is k over x squared raised to the power 9 minus r. Then what's our B? B is x raised to the power r. Now we need to find ways in which we are going to expand and simplify this. Our target is we need to find the value of r. Then after that, we need to get rid of x so that we are able to find the value of k. Right, so now let's find the value of r. So 9 combine r. So we know that according to the indices, this power 9 minus r must be distributed to k and also to this one. Now for this to make sense, I'm going to do this. I'm going to say k raised to the power 9 minus r. Then x, I'm going to take the x squared to the top. So this will change to x raised to the power negative 2 multiplied by 9 minus r. Then this part will be x raised to the power r. Right, so we move on to 9 combine r is equal to k. So multiply by k raised to the power 9 minus r. Then I'm going to distribute this to 9 and negative r. So giving me x raised to the power negative 18 plus negative 2 times negative r will give us 2r times x raised to the power r. Now at this point, I'm going to take this expression and equate it to 0. So that's what I'm going to do. Since we know that the bases, if the bases are the same, we can add the powers. So we are going to say negative 18 plus 2r plus r is equal to 0. Then we know that we can add these two, giving us 3r is equal to, then I'm going to shift this number to this side, giving me positive 18, which is if we divide by 3, we divide by 3, then what's our r? R is equal to 6. So we found the value of r, which is equal to 6. Now let me just get rid of this. So what I'm going to do now, I'm going to write this expression. So the expression is 9, then where there is r, I'll put 6, multiply by k raised to the power 9 minus 6 times we have x raised to the power negative 18 plus since r is 6, 2 times 6 is 12, so we have a 12 times the x raised to the power 6. Then at this point, we are going to say 9 combined. So 9 combined 6 is equal to k raised to the power 9 minus 6 is 3 times x 18 plus 12 will give us negative 6. Then times another. So we can just cancel this because we know that negative 6 plus 6 is 0. So which is now we have 9 combining 6, which is k raised to the power 3. So we are told this expression is equal to this number. We are given 61,236. So now let's create some spaces. So let's create space here. So we need to find the value of 9 combined 6. So what is the formula for us to find this? So say C of R is equal to n factorial divided by n minus R factorial times R factorial. So this is the formula that you are supposed to use now to find the 9 combining 6. Right. So where there is C, where there is C, we need to put 9. So say 9 combining, here we put our R is 6. So 9 factorial would be 9 times 8 times 7. So you multiply by the integer up to 1 times 6 times 5 times 4 times 3 times 2 times 1 divided by n is 9. 9 minus 6 is 3. So 3 factorial is 3 times 2 times 1. Then here, our R is 6. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So I can cancel this and also I cancel this number. So on top I have 9 multiplied by 8 times 7. So I'm getting 504 divided by 6. So 504 divided by 6, getting 84, which simply means that here I'm going to have 84 times k raised to the power 3 is equal to 61,236. Right, so here we are just going to divide by 84 and also here by 84. So k raised to the power 3 is equal to, what is the 61,236 divided by 84. So I'm getting 723. Then we take the cube root of the both sides. So what's our k? So if you use now the calculator, just equal to 9. So this is our final answer. Now for question 7b, we are told to find the term, the third term, the expansion of 1 minus 2x times 2 plus 3x raised to the power 6. So how can you expand this? Now if you look at the other bracket, this one, it's very tedious for you to expand 2 plus 3x raised to the power 6 in form of bracket because you need to multiply these of the same type 6 times. So now we can use now the binomial expansion to bring that, and for us to maybe simplify our work, we can now use the Pascal's expansion. So we have one here. So I'm going to say 1 plus 1, we put a 2 here, then I put a 1, another 1. Then 1 plus 2, I put a 3, even here 3, we have 1, 1. So let's hope by now you've gotten the concept. So here we are going to have 4, 6, 4, 1. Then we are going to have 5, 10, 10, 5, 1. Then we are going to have 6, 15, 20, 15, 6, then 1, 1. So our focus, we are going to use this column since our second number is 6, which is corresponding to this coefficient of 6. So that's what you're supposed to do. So let me first expand this part here. So this is my focus. So how do? You begin with the first number 1. So you take 1 multiply by this 2 raised to the power 6 times the other one 3x raised to the power 0. So you need to make sure that if you add 6 plus this 0, you need to get to the same exponent of 6. So we're going to repeat the same. So plus, so the second one is 6. So say 6 multiplied by 2 raised to the power 5. So this power should be reducing by 1. Then this one will be increasing by 1. So the next one will be 3x raised to the power 1 plus we have 15. So 15 times 2 raised to the power 4. Then here we are going to have 3x raised to the power 2 plus. So the reason why I've ended at the third term, it's very long if you are to complete it. So we just look at our third term since we are told the third term. So that's our focus. So what is the 2 raised to the power 6? So 2 raised to the power 6 is 64. We know that this will give us a 1 plus what is 2 raised to the power 5? We get 32. 3x plus we have 15. What is 2 raised to the power 4 is 16. Then if we expand 3x times 3x will give us 9x squared plus. So 64 times 1 will give us 64 plus what is 32 times 3? 32 multiplied by 3 times 6. I'm getting 576x plus go 16 times, so I'm multiplying this by 9. So 16 times 9 is 144 times 15. So I'm getting a 2160x squared plus dot dot dot. So at this point, we have done expanding this part according to the position that we want the number. So what I'm going to do now, I'm going to get the other expression multiplied by what we formed. So get this expression, which is 1 minus 2x times this expression. So we have 64 plus 576x plus 2160 squared plus dot 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 dot. So let's distribute. We know that 1 times 64 will give us 64 plus 1 times this will give us 576x. 1 times this will give us 2160x squared. So move on to this one. Negative 2x times this one will give us minus 128x. Then negative 2x times this. So we're going to have a negative. What is 576 multiplied by 2? So I'm getting a 1152. Now this x raised to the power 1 times this x raised to the power 1 will give us x squared. So this should be 1. Okay, just so this should be 2x squared. Then the other one we just multiply. Okay, we can multiply now. Negative 2x times 2160x squared will give us minus. So 2160 times 2, getting negative 4320 x raised to the power 3 ... So we have 64 plus 576x plus, let's collect the like terms, so minus 128x, then plus 2160 x squared minus 1152x squared minus 4320 x cubed ... So we have 64 plus 576 minus 128, getting 448x. Then 21 60 minus 1152, getting 1. This should be plus 108 x squared minus 4320 x to the power 3. So we can say, therefore, the third term of this expression. So you write the expression. So let me just write it here. The third term of 1 minus 2x times 2 plus 3x raised to the power 6 is, so the third term is this part here, because it's a number on position number 3. So is 1008 x raised to the power 2. So this is our final answer. So let's hope you are able to understand that. So that's it for this video. Thanks for watching.